Hi, everyone. This is Gail Queen, and I am going to be talking to you today about linear functions and slope. So this will be helpful for you in several different courses. Maybe you've seen this before in the previous course. If you have, you'll be ahead of the game. And if you haven't, then I'll get you caught up to speed. All right, so linear functions are functions. When they use the word linear, first of all, in math, that word means something and you need to become familiar with the word itself. So when you see this word linear, obviously we see the word line embedded in there, but it really means more than just line. When you have a linear function and it's given to you in the form of an equation, then linear means that all of the variables in the equation are going to be to the first power. So if we start looking at these examples I have on the screen, you've got the first example here, x plus y equals 2. Notice how x is to the first power and y is to the first power, because both of the variables in the equation are to the first power. We know this is a linear equation, and when I graph it, I'm going to get a straight line. Similarly, we've got the second equation here, x and y are both again to the first power, so this is a linear equation. The third example, we have y equals -5. Now this one's a little bit different because the only variable in my equation is y. I don't have an x in the equation, and that's okay. The only variable in the equation is y, and that y is to the first power. Therefore, this is a linear equation. Same thing is true here on this last one. We have x equals 1. The only variable in the equation is x, and the only variable in the equation is raised to the first power. Therefore, this is the linear equation. Now, the bottom two are some counterexamples. Notice how in this bottom equation, y equals x squared plus 6, the x is being squared. The x is not to the first power. The x is to the second power. So this is not a linear equation, okay? Not linear. And then the last equation here, x squared plus y squared equals 9, both of the variables are to the second power, not the first power. See those exponents of 2? So this is also not linear, okay? If any of your variables are to the second, third, fourth, 1/2, -6, if any variable in your equation is not raised to the first power, then it is not a linear equation. All right, so in our examples, the top equations are linear and the bottom equations are non-linear. Okay, now types of lines. When we're talking about a linear equation, we do graph them and get straight lines in the xy plane. There are many different kinds of lines. This particular line on the screen is going uphill from left to right. So let's talk for a minute about how we read graphs. Everybody has to read this the same way or we could get different answers. So always, I don't care what math class you're in. I don't care if it's a math class. I don't care if you're reading a graph in a newspaper, if you're reading a graph in an economics class, if you're reading a graph when you're looking at your stock market information. If you're reading a graph, we always read graphs from left to right. All right, so if we're all reading the graph from left to right, we're all going to have the same interpretation. So you read it the same way you would read the sentence written on a sheet of paper, left to right. So this will prevent ambiguity. If we were not all reading it the same way, then some people might say, oh, this line is going down. It's a downhill line because see, it's going down over here. But then other people might say, no, see, it's over here. The arrow's going up. So it's an uphill line. Well, which is it, downhill or uphill? Well, when we read this graph from left to right and we start at the left and go to the right, this is going uphill. And everybody agrees that it's an uphill line. Does that make sense? So make sure you're reading your graphs from left to right so that we're all interpreting it the same way. That's going to be really, really important. Okay, now with this, we do have some different options that are going to occur when we graph lines. If I look at an equation and I see that everything's to the first power and I know that I have a line, then we got to look at the kind of lines we might encounter. First, the first graph here on the left side of the screen is uphill. As I read the graph from left to right, it's going uphill. And that means that the tilt of the line or the slope of the line is going to be positive. So when you're going uphill, you have a positive slope. If you are going downhill, like the second line, when we read this one from left to right, it's going down. This will have a negative slope. And when it is horizontal, the third example here, horizontal line, this is flat. It's not going uphill. It's not going downhill. It's literally just a flat street. Okay. Horizontal line. That means that the slope is, there's no slope. It's zero. Okay. It's not a positive number. It's not a negative number. It's zero. And then the last kind, this kind is the weird one. It's the standout one. Okay. If you have a vertical line, then it is going straight up and down. And we say that the slope is undefined. Now, a lot of people get these two mixed up. They get mixed up between when is it a zero slope and when is it an undefined slope. And so here's how I want you to think about it. If I were to ride a bicycle, don't laugh at my silly pictures here. So I got my bicycle and I'm going to ride my bicycle on the line. Okay. So I can ride uphill. That's not a problem. So we are allowed to ride uphill. Uphill has a positive slope. If I'm riding my bicycle and I go downhill, riding downhill, we have a negative slope. I can ride my bicycle along a flat level street and there is zero slope. Okay. Can you ride your bicycle up a wall on a vertical line? I cannot ride my bicycle here. And so that's the one. If you cannot ride your bike on it, then it is a vertical line, and that means that the slope is undefined. You are not allowed to ride on a line with an undefined slope. Okay, so this is important that you think about the tilt of the line, whether it's an uphill positive slope, downhill negative slope, flat horizontal zero slope, or a wall straight up and down. That's the one with an undefined slope. All right, moving on. So we're going to categorize these. Now, these are Queen terms. This is Queen terminology here. You're not going to see this in my math lab. This is a tilted line. The first two cases of lines are called tilted lines. That's how we're going to refer to them. Now, we may not know exactly if it goes uphill or downhill from the equation yet. We're going to learn that later. But I can tell if I have a tilted line or whether I have a horizontal line or a vertical line. And I can tell you whether it's tilted, horizontal, or vertical just by looking at the equation. When we look at the equations, okay, a tilted line, the equation will have both x and y. You're going to see both variables in the equation. Okay, so that's a dead giveaway. So if I look at an equation and I have both x and y, and both of these are to the first power, I know it's a line and I know it's a tilted line. I may not yet know which way it's tilted, uphill or downhill, but I do know it's a tilted line. On the other hand, if I have an equation and my equation has only a y, I only have y, like the equation y equals 5. This is the equation of a line. I know it's linear because the y is to the first power. However, there's no x in the equation. When you have no x in the equation and all you see is y, that is a horizontal line. That means it goes straight across. It's not uphill. It's not downhill. It's like riding on a flat street. Okay. Horizontal lines only have y. There's no x involved. Vertical lines, similarly, only have an x. So if you have an equation and you've looked at the equation and all of the variables in the equation are to the first power, then you have a linear equation. So my little equation here is linear, but there's no y in the equation at all. All I have is an x. So when you have x only, it is a vertical line. Okay. So we can tell right away what kind of line we have, tilted, horizontal, or vertical. So we're going to practice, all right? Make sure you catch on to this. It's going to save you some time when you're doing your work if you can do this. So when they hand you an equation, what I want you to do is ask yourself two questions. First, is it linear? In other words, are all of the variables to the first power? If it is linear, then I want to know, is it tilted, is it horizontal, or is it vertical? Tilted has x and y in the equation. Horizontal has y only, there's no x. And vertical lines have x only, and there's no y. Okay, so let's look at example number 1 here. We have x plus y equals 2. All right, so this is a tilted line. I originally had this as a PowerPoint, but it was harder to write on the PowerPoint, so I am rolling through. So bear with me as we roll through, okay? So line number one is a tilted line. The reason it's tilted is because it has both an x and a y. Now let's look at line number 2. All of these are going to be lines. They're all variables to the first power. All right, so the second example is y equals 5. I'm sorry, y equals -5. So this is y only. That means that it is a horizontal line. When your equation has y only and there's no x at all, then you have a horizontal line. Okay, that means it's like a flat street. It's not going uphill, not going downhill. Okay, number 3. So here we are with number 3. This has an x and a y. Therefore, this is a tilted line. It has both x and y. And then the last one, of course, is our vertical line. This equation only has x. There is no y at all. When you have no y, you have a vertical line. This is like going up the side of a wall. It goes up and down, vertical line. Okay, so here are some other examples. And here I put these in especially. You need to be careful and not look too quickly because they will try to mess with you a little bit. Okay. All right. So the first one is pretty straightforward. You've got both an x and a y in the equation. This is a tilted line. Now look at the second example here, number 2, and be careful as you're looking at it. Okay. All right. When I look at the second equation on this page, all right, it looks very, very similar to the equation above. But if you notice in this equation here, there is no y variable. What does it mean when you have no y? When you have no y and all you have is x, that means you have a vertical line. Okay, so even though they're trying to format it where it kind of looks like a tilted line, this is actually a vertical line. So what we would do with this vertical line, if I had to work with this vertical line, I would never leave it in this form. They're only putting it in that form to try to trick you. So watch and be careful, okay? All you have to do is solve the equation for x. So I'm going to move the -3 over to the right-hand side of the equation. So it'll be 6 plus 3. When we move it across the equal sign, it'll change from a -3 to a +3. So now I have 2x equals 9. And finally, to solve for x, we're going to divide both sides by 2, and we end up having x equals 9/2. Whenever you have x equals a number, any number, it doesn't have to be a pretty integer number. It can be a fraction or a decimal. X equals a number is a vertical line, okay? So be careful. All right, and the last example on this page is y equals a number. It's going to look like that. Here's our number 3 for this page. All right, so we have y plus 4 equals 3. So notice here that in this equation, there is no x. When there's no x, you have a horizontal line. If all they're asking you for is the line vertical or horizontal, you don't have to do any work at all. You can just say it's horizontal. But if you really wanted to work with it, or if you had to graph it, you would want to go ahead and solve it for y. So I would bring the 4 across to the other side. When you bring that positive 4 over, it'll become a negative 4, and we end up with y equals negative 1. All right, so you've got these little equations here. So I want you to start getting used to working with linear equations. And when they start giving you equations, before you do any work, before you answer any homework question, I want you to look at the equation and ask yourself the question, is it tilted, is it horizontal, or is it vertical? Okay. Now, there's one other thing they can do to try to screw with you and trick you. And that is, we talked about function notation earlier. So let me find a different color to work with here. All right, so do you remember that another way to write the y equals blah blah x stuff is to write f of x equals blah blah x stuff. We did talk about this in the other section. So I can either write y equals or I can write f of x equals. Y and f of x mean the same thing. So another thing that they can do to trick you on this linear function section is they may write something like this. Here's our example. We want to know, is it tilted, horizontal, or vertical? And they're going to write f of x equals negative 6. Now, when you look at this equation, f of x equals negative 6, you need to remember that f of x and y are the same thing. They're really giving you y equals negative 6. So is this tilted, horizontal, or vertical? So you only have y. There's no x involved. This is horizontal. So do not be thrown off if they give you the f of x notation for y instead of giving you y, okay? Watch for that. That's a little tricky. I have some of that in my math lab, so be aware, okay? All right, so here's what we know so far. Now I can look at the equation of a line and I can answer these questions. Is it linear or not? We look at the power of the variables. If every variable in the equation has a power of 1, we have a linear equation. That means it will graph out to be a line. Further, if I do have a linear equation, then I can ask myself, is the line tilted, uphill or downhill, horizontal, flat like a flat street, or vertical, up and down like a wall? I can tell from the equation whether it's tilted, horizontal, or vertical. So that is the first step and the first start to working with linear functions.